My name's Professor Jean Anne Incorvia. I'm an assistant professor at UT Austin in Austin, Texas. So my background is in physics, actually. I did my undergraduate degree in physics at UC Berkeley, and then I did my PhD in physics at Harvard University, also working in electrical engineering at MIT. And I did a postdoc in electrical engineering at Stanford, and I started at UT Austin. I'm in the electrical and computer engineering department 5.5 years ago. So I run a research group there. We're called the Integrated Nano Computing, or INC Lab. I have about currently 12 graduate students, 2 postdocs, and about 7 to 10 undergraduates. So it's a pretty big group these days. Our specialty is in how to use new materials and new physics for computing. So that's really where my core of my research is. Within that space, we focus on 2 material classes: magnetic materials and 2D low-dimensional atomically thin materials. And so that's how I got connected to this program. It's a great opportunity at UT Austin that this UT Austin Portugal program exists, and I can apply to this more selective call between our 2 places. So I think it's a great program. I think I went on the website, and what I say on the website is you can post your specialty and what you're interested in, and then get connected that way. So I think that's really nice, because how do you actually form these connections? So that's how Arthur and I met through there. Yeah, so my interest in this project actually came because I traditionally work on 2D materials for computing, and I went to a conference on commercialization of 2D materials, and I saw that while the use in computing is really exciting, it's challenging in its own way. And some of these near-term applications of solution processed 2D materials for cancer, for health, and also for other materials seems to be a near-term opportunity for these types of materials. So that's what got me interested in working in this space. And so it's a new space for me. I am an expert on the materials, but I am not an expert on the applications to the cancer therapies. But I've been learning a lot over our 1-year collaboration so far. And so, from where we're at is that Arthur has done a fantastic job of introducing graphene into this application of cancer therapies with light and heat, and we really want to extend the expertise to this whole library of 2D materials that are available for this application. Yeah, so I think this has been a great program for me to expand my boundaries and get into something different. And one reason I became a professor is because I have a lot of varied interests and I want to make impact. And so it's been a great opportunity to connect, and through these connections, take my research in a new direction. I think it's very healthy for my group to have these different directions that we're working on and leverage our expertise in these materials. Yes, so we had our 1-year collaboration. We already submitted a proposal for an extension, hopefully, to a new project. And then we are already working with new collaborators we're bringing in, more on the material synthesis side, and things to extend even newer materials that are only just being synthesized. So I think there's a lot of room to grow on the material side. And then, as we just saw from these presentations today, there's a lot to do now that we've shown that these materials can heat under light on the cancer therapy side. So actually integrating them with the cells and seeing their effect and their benefits. So I think it seems like it has promise to make real world impact.